all, before we get into the theorems, we need to make sure we understand what's going on here. I have drawn here an isosceles trapezoid. Remember the definition of an isosceles trapezoid is the the non-parallel sides are congruent. So TP and segment RA are congruent. Okay. There's two pairs of base angles on a trapezoid. They don't have to be an isosceles trapezoid to still be considered the base angles. And I have them circled here. P and A are base angles. And in an isosceles trapezoid, we're going to figure out in this theorem here in just a second, those base angles are congruent. Also, angles P and R are base angles. And so I know at first glance, someone could say, well, that means that all four of them are base angles. But understand they come in pairs. For example, what I'm saying is, these two are not base angles. Okay? Angle T and angle P together don't make base angles. Angles P and angle A make base angles, and angles T and angle R make base angles, but not the other way. Okay? So when you're talking about base angles, you're talking about a pair of them, and you have to match them up, either the ones on the bottom or the ones on the top. Okay? So the isosceles trapezoid theorem, anybody not done with the picture? Okay, let me move down then. It says base angles in the isosceles trapezoid are congruent. That's all it says. Very simple, straightforward. The definition tells us the non-parallel sides are congruent. So the theorem tells us the angles, the base angles, the pairs of them are congruent. Okay, a couple more theorems. No special names on these. You notice I do not put the numbers on there. I don't want you remembering this as theorem 6.4 and theorem 6.5 and theorem 6.6. I have no idea what the numbers are. I'm pretty positive they're not those numbers though, since we had 6 a couple days ago and we had 4 yesterday, and we've had quite a few theorems. So the next theorem says diagonals in isosceles trapezoid are congruent. What other diagonals are congruent?
Rectangle.
Rectangles, good. Move this up just a little bit and I'll pause it so you can copy the one down below. And then diagonals of a kite are perpendicular. What is the, what other shape or quadrilateral has perpendicular diagonals?
Rhombus.
A rhombus. Okay? So there's some similarities here, and that's what makes this difficult. So you want to make sure your notes are good so you don't get confused. You can go back and look at them. So here we have a kite. I can tell it's a kite because why? How can I tell that's a kite? Say it loud. Well, answer my question for me, please. How can I tell this a kite? Thank you.
Has two same pair.
2 pairs of
I don't know. That's two pairs. I don't know. That's two.
help him out. He's good, real close. 2 pairs of what? 2 pairs of congruent sides. And opposite sides are louder? No? Not something.
Parallel.
Not parallel. Okay? In other words, it's not a rhombus. I could have 2 pairs of congruent sides. And if opposite sides were parallel, then it would be a rhombus. Okay? So they throw that in there and say they can't. Now, some books, we had a book one time that connected kites and rhombuses together, and they didn't have that opposite sides couldn't be parallel, and they were saying that a rhombus was a special condition of a kite. Okay? So there are some books that would define things differently, but our book does not define it that way. They very clearly say that a kite cannot be a rhombus by telling us opposite sides can't be parallel. Okay? So here we have a kite, because we have two pairs of congruent sides, those two and these two. And that means these diagonals are perpendicular, making that angle there a 90-degree angle. Okay? So here we have an example. Based on how this is marked, what is this picture?
Trapezoid.
It's a trapezoid.
Isosceles.
Don't be afraid. Yeah, it's an isosceles trapezoid. Don't be afraid to turn your book around and look at things the way you like to see them, the way you're used to looking at them. You guys will ask me questions and I'll come up and go to help you, and the first thing I'll do is grab your book and start rotating it around on your desk. So you're looking at it a different way. A lot of times your confusion is simply because the picture's not sitting in the position you normally look at it. So don't be afraid to turn it around and look at it the way you're used to looking at it. The writing I had on here is kind of difficult to see, but this was 111 degrees. Angle 1, 2, and 3. My parallel lines as my basis now. What rule did we just learn about base angles of an isosceles trapezoid? They're congruent. So what's measure angle 3? 111. Is angles 1 and 2 111? How do I know with 100% certainty that angles 1 and 2 are not 111 degrees?
They're a lot smaller than those angles.
Okay, but not because of their looks. How do I know? How do you know they're smaller?
Same side interior angles.
No? Well, that's going to be important to answer the question, but how do I know this, 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 and this are not all 111 degrees?
They're not all the same bases.
Okay, they're not, but what shape is this? And the most generous name, generous, I didn't mean to say generous. The most general name of this shape is a what? Quadrilateral, because it has 4 sides. And what do the 4 angles of quadrilateral have to add up to?
360.
360. There's no way all 4 of them could be more than 100, is there? 100, 100, 100, and 100. That's 400. That's already more than 360, regardless of the extra 11 each one would have had. Okay? So the 100% certainty, I know they can't all be 111. Now, Jackson has already said that if he extends these, I love the way you said that yesterday. Sounded like me. If you extend those sides, we have same side interior angles going on. And since these two lines here are parallel, then those same side interior angles have to do what? Add up to 180. Good answer. And so that means measure of angle 1 plus 111 degrees, equals 180 degrees. So measure of angle 1 is going to equal 69 degrees. Okay? So measure of angle 1 is 69 degrees. Do I have to calculate measure angle 2? No. What is it? Because
Opposite angles. Or
base angles are congruent. So 1 and 2 are a pair of base angles, so they're congruent. Okay? Good. Any questions on that? Take 30 seconds in your group to answer this question while it's talking. One thing I should have pointed out is that this is a kite.
12 degrees.
I should have made that obvious. It's not obvious by the picture. If I turn this around, so it looks like this, we could prove that these two triangles are congruent. Okay? Using HL. The right triangles, right? Because these lines are perpendicular. That makes angle 1 what? 90 degrees. Okay? Because they're perpendicular, I can use HL. Kite, definition of kite says those sides are equal. This is equal to itself. So I have a hypotenuse and I have a leg. So I can use HL to prove those triangles are congruent. Okay? I can do all that. Now, because I could prove that, in our previous book, we had a theorem that pointed this out. This long diagonal is contained on this line that I drew through here. So the long diagonal is always going to be a symmetry diagonal. Okay, and I'm just telling you this so that you don't have to think through all that other process. You can just remember, if this is a symmetry diagonal, then that means it cuts these angles into two equal angles, and this one into two equal angles. Means everything on this side is exactly the same as everything on the other side. Okay? That's what a symmetry line would do to it. You cut it right down the middle so that one half is exactly the same as the other half. Alright? So, if you look at it that way, this is 90 degrees, so this is 90 degrees, this is 22, so this is 22. What does 90, 22, and angle 2 have to do? Add up to 180. Okay? And I'm pretty sure I heard that in most of your groups. So measure of angle 2 plus 22 plus 90 equals 180. A lot of you realize, well, if 90 is one of them, the other two must add up to what? If 90 is one of your three angles, what do the other two angles have to add up to? 90. And so some of you might just want to start here. You don't have to show me that first step that I had up there and add all three of them up and make them equal to 180. If you recognize one of them's 90, then the other two have to add up to 90 to make 180 total. And so you could start with this step right here. So the measure of angle 2 then is going to equal 68, is that right?
Yeah.
68 degrees. Okay? A group not get that? Like you're going to volunteer that information to me, huh? You got it, right? Okay. Take another minute in your group. Make sure you know how to do this one. Good. Anybody not done? You're not done? Kayla, what'd you get for angle 1? 90 degrees, because the red lines are perpendicular, because the rule says the diagonals of a kite are perpendicular, so that makes this 90 degrees. Okay, good. How did you find angle 2, Brandon?
I took angle 2 and then added 90 and then 38 to it and equals 180.
Okay, good. So you're saying these three angles add up to 180. So would it be true to say those two angles add up to 90? Okay? So angle 2 is going to be 90 minus 38, which is 52. Is that correct? Okay. Let's measure angle 3. Jeffrey? What's measure angle 3? 38, because?
Did you get 52?
It's not the opposite of 1. what we just talked about a moment ago. The symmetry line's gonna cut that in half, so the long diagonal is that symmetry line. What's measure angle 4 going to be? Here's where some people get confused. They wanna say these two are the same. Are 2 and 4 the same? No, they're not. So how am I gonna find angle 4, Hunter?
Same way you found angle 2.
Okay.
The different triangles.
In a different
So-
triangle, so tell me what to write.
90 minus 53.
90 minus 53. He's saying this is a right angle, and so the other two add up to 90. So 90 minus 53 is angle 4, and that is 37. And what's angle 5? 53, the same as the one above it, right? Symmetry says so. 53 degrees. Okay? Any questions on that? And then this is, if you hadn't written down what I told you, you should write that down. The long diagonal of a kite is also the symmetry diagonal. And we can prove that, writing a proof of triangles like we did last unit. But I'm not expecting you to, I just want you to understand it, and know it, write it down and have it. So the long diagonal of a kite is also the symmetry diagonal. Another example, what is the shape I have here? What kind? An isosceles trapezoid. How do I know it's isosceles? The non-parallel sides are congruent, aren't they? These marks right here, they tell me that those non-parallel sides are congruent. So what's true about this picture there if it's an isosceles trapezoid?
The diagonals are congruent.
Yeah, the diagonals are congruent, so that means RT is equal to SU. The distance from R to T is equal to the distance from S to U. And RT is same as TR, so that means 2x minus 3 equals SU, which is x plus 1. So if I move my x first, subtract x from both sides, I get x minus 3 equals 1. Add 3, x equals 4. Now if they ask me to find TR, what would I do? What would I do if they asked me to find TR?
Plug in the
2.
Plug x in for here. Okay. You mean plug 4 in for x right here? So 2 times 4 minus 3. What's 2 times 4? 8 minus 3 is 5. So TR is equal to 5. What's SU going to be? 5 also. 4 plus 1 is 5. And that confirms what we said, they need to be equal, right?
Yep.
Okay. Good. Any questions on that? Anybody not finished with this one? So your assignment then is 1 through 33 odds on lesson 6-5.